Good afternoon and welcome to the 2021 RUSD Career Technical Education Showcase, Engineering Design, Architectural Design, and Robotics and Engineering Systems Industry Sector panel discussion. I am Mike Martin. I teach in the engineering program at Martin Luther King High School, and joining me is Mr. Nick Mugridge, who's our district CTE liaison. Today we're joined by 5 senior students in our program: Natalie Martinez, Tyler Martz, Caleb Tate, Jonas Taylor, and Zach Goodsight, who have finished all 3 industry sectors in their 4 years at King. Today, our students will share their experiences in CTE and how they've pivoted their career engagement, academics, technical mastery, and professional skills during this school year. I will start by asking some questions. Is everybody ready? Zach, we'll start with you. What kind of academic knowledge have you gained this year in your program?
In my CIM class with the robotic arm, I've learned a lot about coding and how the manufacturing process uses the robotic arm and other types of processes and how useful it can be.
Right on.
Can I ask a quick follow-up to that question, Zach?
Yeah.
How has that knowledge connected to the career content you learned?
It's shown us a lot about like how to pick up certain objects and do different tasks with them, and it's like.
So what's an example? What's an example of a task that you'd have done?
Oh, we like pick up a block, put it over a sensor that would detect if it's either metal or plastic, and then put it in a certain bin based on that information.
So what would be like an application of that in the real world, since we're talking about careers, right?
In manufacturing process, or like some sort of distribution where you have to sort out items, and like Amazon warehouse or something like that.
Cool.
All right, very good. Thank you. Tyler, let's pick on you for a minute. Explain some of the hands-on technical mastery and know-how you have engaged with in your CTE program. So during the course of the 4 years, talk about some of the hands-on and technical mastery that you've done.
Yeah, so because there's about 6 classes, each of them generally focus on a different subsection of engineering. IED, Intro to Engineering Design, and POE focus more on Principles of Engineering, focus more on basic engineering knowledge. So stuff that practically every engineer needs. So IED focused more on modeling stuff in like Fusion 360 or Autodesk Inventor, CAD modeling, that kind of thing. While POE focused more on, the math side of engineering, how to calculate gear ratios, that kind of thing. Like coding a robot, problem solving with code, that kind of thing. But I think probably like the one that gave me the most hands-on technical mastery was definitely CIM, which is Computer Integrated Manufacturing. We got to go to like, field trips, that kind of thing, get to see the manufacturing side of different factories. And in CIM, we learned how to code a robot arm and use it to execute certain tasks. We also learned about the many different sides of manufacturing. Like there's the logistics side, there's the side of like designing and building robots, there's the side of actually using the robots. And there's also stuff about like Six Sigma, for example, which is, 6 parts per million is allowed to be a defect in manufacturing processes. There's that kind of thing. We also were taught in CIM to understand some binary, not as much as in the DE class, digital electronics, but we did learn some. And there's a lot of really interesting stuff like that. And I think another one that like gave me a lot of hands-on skill was definitely digital electronics. That one I got to learn, binary, hex code in more detail, and logic gates. As you can see behind Mr. Martin right now, those are some logic gates right there. And Boolean expressions, which relates to logic gates, and also how to like use computer chips and soldering and all that kind of thing. And I think the soldering side is definitely one of my favorite parts. We got to solder different circuits together, and we even got to use breadboards and some wiring ourselves, just like build our own circuits that we designed on a Multisim, which is like an online designing platform for circuits.
Very nice.
I want to ask you a couple of follow-up questions for you, Tyler.
Yeah.
I'm going to backtrack just a little bit to number one, because you brought it up. some math.
Yes.
And how you have used, or you can tell me, how have you used some of your math knowledge? What kind of math knowledge did you need before you were in the program? And what math knowledge did you need to also gain during the program? And how you applied it to some of the technical stuff?
Yeah, exactly. For that one, beforehand, you needed about like an algebra level understanding of math. It wasn't really calculus level. But some parts of it did relate to calculus. You just used algebra to solve it. So I think the best example of that was the center of mass calculations you had to do. So in POE, Mrs. Guzman taught us how to figure out the center of mass of certain I-beams and stuff like that. And the reason why that's very important is because when you're building a bridge, you need to know the center of mass of the construction material you're using, so you know how to best support it, right? Because if you have an I-beam like this, sort of like that, but you support it on this side, it's not going to be as sturdy as compared to underneath here, or closer to the center of mass. And we used algebra in order to solve certain cross sections in order to see where that center of mass is, depending on what it looks like. And that was really, really useful. And we also learned to apply that in order to design bridges. In that class, we learned how to use like some modeling software in order to design bridges. And we learned a lot about like truss forces, that kind of thing. I never knew about truss forces beforehand, but whoops. But with truss forces, we learned what at what point does a bridge fail and how best to make a bridge last and not fail as easily and handle higher loads and that kind of thing.
I think Tyler's trying to take my job from me someday, huh? Those are great answers, Tyler. Thank you.
Thank you.
I'm going to pick on Zach again for number 3, because number 3 has some relations to Skills USA that we were actually talking about before we started the meeting. Question number 3, what are some non-tangible professional skills that you've developed along the technical and academic content? I know that we spend a lot of time in Skills USA doing professional skills, but Zach, can you talk a little bit, because you did Skills USA? Can you talk a little bit about those professional skills? And Jonas, I'm going to follow up with you.
Skills USA taught us a lot about how to present our engineering work and how to be professional and talk to people with importance and seriousness like you would in a business life. And it showed us how to present all of our work and show our product and kind of show it off and give like a really professional look to what we do in class.
During the course of that time, were you ever required to turn in a resume? Did you have to develop a resume for that?
Yeah, we developed a resume with all our skills and strong points we had developed in the program.
All right, very good. Jonas, during the course of your time in the program, did you learn any professional skills, these non-tangible, some used to call it soft skills, we're now calling it professional skills. Have you learned any of those as well?
Yeah, well, being able to go through the engineering process and to be able to understand it. What I've learned is that engineers are just problem solvers. And that's one of the skills that we've learned, is just how to be a problem solver and to solve these problems. Right. Like, for instance, for our capstone project, we had to go out, find a problem that needs fixing, and find a solution to it. So I think it's really cool to be able to develop these skills of problem solving and leadership also, when you think about it, because you have to be, you can't just sit by the sidelines. You have to be the one spearheading these projects, because if you don't spearhead it, then no one else is going to. So being able to develop these skills of leadership and problem solving is really what an engineer is. That's basically what it's all about when you get down to the meat of it.
That's a great answer. Yeah, thank you, guys.
Totally true.
Yeah, this is really great. This is great. Natalie, I'm going to pick on you for number 4. What are the most important skills that you offer to professional or to potential employees? They're certainly looking for certain skills, but those skills that you think they're looking for, what are the most important skills that you can offer to potential employers?
Well, I feel like following what Jonas is saying about problem solving, even in the 6 courses that we take throughout the 4 years, you come across problems with anything that you're programming or building. and you have to figure out how to fix it. So I think problem solving is also important. And I also want to note that from my personal experience, teamwork, because prior to engineering, I was the type to mostly work by myself. And so having to do like our capstone project, that's a team, and in POE and even CIM and digital electronics, you're sitting with a partner, you're working with them on these assignments. So I think that's, especially in engineering, I think that's more important too, because it's not just a civil engineer or just an electrical engineer. They're all kind of working together for a project. And
Good answer. You know,
also, like a brief thing about experience, because some of the classes you're working with software that is used professionally and skills that are used in the actual field.
very good. Nick, any follow-ups?
Yeah, I think that's a really good point. I'm actually gonna follow up with this question here, and I'm gonna ask Caleb, if Caleb's ready. How has your experience in this program this year especially changed the way that you think about the variety of career possibilities in the related industry sector? Because I think, you know, when people say engineering, right?
Yeah.
There's like this tunnel vision people have about an engineer. Oh, you're just an engineer, right? But I think, you know, as you guys go through this program, hopefully you find out a lot more than that. Can you tell me a little bit about what you have found on your journey?
Yeah. So as you're saying, when people think of engineer, they're thinking of some type of like mechanic, someone working with just a bunch of like mechanical systems. But from this program, I've seen as an engineer, it applies to so much more. For example, like buildings, just making any like, I don't know, a video game, any electrical systems, or just, I don't know, almost, I don't know, it's so much because like even with like for civil engineering and architecture, we call it the engineering curse, because when you see it, you just realize that engineering applies to almost everything, even with like manufacturing and just so much. I'm sorry.
Well, one of the things we've talked about, I don't know how much we've actually talked about this, but remember that everything that you use, whether you're sitting in a chair, sitting at a table, the camera that you're looking into, was developed by an engineer. An engineer did this. And so, you know, like you said, this engineering curse, everything was touched by an engineer.
Thank you, Caleb. Do any of you, the rest of the four of you, have any comments about that question, about what kind of exposure and variety of career choice have you encountered that was maybe interesting that you didn't know existed before? Anything like that?
I'll go ahead and jump in here. I think probably the most interesting part, something that like really pulled the wool for me, was definitely our CEA class, our Civil Engineering and Architecture class, because it really goes into detail about like, one, the many different types of architecture, the many different types of designs they have, and which I never really thought about. You know, like just basic roof designs, there's hundreds of different types. And then there's also different house designs, you know, like if it's a one-story house, you know, what kind of house that is, that kind of thing. And it also definitely, I thought like the most interesting part was how they build commercial buildings. So there's actually 3 different types of main cement that they use. There's like flip-up cement, where they actually manually, first they like make the cement in a horizontal plane, then they lift it up using a type of crane design, which is another engineering field, right? And they install it onto you know, a certain design. And that's just like one tiny little part of you know, civil engineering and architecture. And that's not even focusing on the civil engineering part of it, right? You know, they have to make sure that it can withstand certain winds. And I think perhaps like the best thing that like really like opened my eyes behind like, you know, what's behind all this was when our teacher, Mr. Dietz, talked about frost depth. I think that was probably the most interesting part, because it never occurred to me at all that you have to build your foundation in a certain way such that when water comes in and then it freezes, it doesn't, you know, crack your foundation. There's actually whole design processes involved with that. And there's even whole design processes involved with getting, you know, water out of certain areas and into other areas, right? So there's no flooding, that kind of thing. And I never really thought about it.
So what you're saying, Tyler, is that these are all different careers inside, you know, you've got this umbrella of architecture, but you've got all these sub areas where people are dealing with concrete and roof design and all that kind of thing.
Yes, and I thought that was like just the most amazing part ever.
Right on. Very good. All right, Jonas, you told me earlier that you actually wanted to answer this question, so I'm going to ask it. How has this program prepared you to stand apart from your peers?
Well, being able to, I think it's really amazing being able, so in my CIM class, we were able to sort of pull back the curtains on some of these cool experiences. So like we were able to go to like a food processing plant, and it really just showed me how much goes into that, because you go to the store and you go over to them. There's all of these boxed foods. You have the watermelon, one just dedicated to watermelons. You have one like a platter with sauces and whatnot. But being able to go and to actually see the process of here's the carrots, here's the dip, here's the celery, and how they're all able just to flow almost in like a just beautifully, I guess. It's just really amazing to watch that process fold out. Like, for example, we went to the Pepsi place, and we were able to see that process and just how it goes from literally from nothing to the Pepsi cans that you see today, and how they're able to fill it, and also other things. We were also able to go and see a showcasing the latest and newest models of engineering, and seeing the efficiency on those, what sort of new grounds they're coming up with. Like at that showcase, you had mechanical, chemical.
Oh yeah, the one over it. Yeah, over and over.
Yeah, the one at the Anaheim Center. It was amazing just seeing all the cool new tech and all the new ways that it can be integrated in like every like part. It's just really cool seeing
so
that.
So standing apart from your peers, just having opportunities to do this. Other people aren't going to have those opportunities, and it's going to.
Yeah, so like just being able to know how to do it, it's really helped me figure out like, okay, so this is the process. You have to have the raw materials. You have to be able to understand the chemicals that go into aluminum in order to make sure that it's strong enough, but you're not using too much.
Zach, let me
real quick, let me jump in real quick, Mike. I just want to say, I think it's interesting, when you ask a question about what allows you to stand apart from your peers. And I think the standard answers are usually things like, oh, I have this skill, or I have that skill, or I learned how to use this equipment, or I learned how to use that equipment. And Jonas just shared with us that just being exposed to these new things can set you apart from your peers, because now you just have that knowledge. It's not even about the skill necessarily.
That's a good point.
It's about seeing that light at the end of the tunnel and going like, oh wow, and then like you said, pulling the curtain back, right? Being able to see behind the scenes, and that alone can set you apart. And I think that was a really interesting point, Jonas. I thank you.
Yeah. Let's go on to question number 7. And this is going to be kind of a rapid fire. I want each person to just spend like 10 seconds answering this question. What is the most memorable or exciting experience you have from working this program? Zach, 10 seconds, go.
I'd say all the building projects, like the hydrogen cell powered card, POE, and the robot arm in CIM.
Natalie, what was the most memorable thing for you?
Making the claw machine in POE.
The claw machine? Right on. Tyler, what about you?
The CIM field trip to the Pepsi plant, where we got to see, like how they use cardboard and everything like that to pack up Pepsi cans.
Right on. Caleb?
I would say the reverse engineering project for IED, and the learning how to use the laser engraving machine and the CNC mill for CIM.
Okay, and Jonas, what was the most memorable? So you may have already answered that, but
obviously the convention center, but I also loved learning how to 3D print and to be able to make cool designs like that.
Jonas was referring to a field trip we did last February to a thing at the Anaheim Convention Center called the Automation Technology Expo, or ATX. And they've been having it every year. Of course, they didn't have it this year, but it's a fascinating fascinating expo that they have. Again, okay, our final question, and again, this is going to be kind of a just 10 seconds. What are your plans for after high school? Natalie, what are your plans for after high school?
I plan on going to Cal Poly Pomona to study civil engineering.
Tyler,
I plan to go to Cal Poly Pomona to study electrical engineering.
Jonas,
I plan on going to BYU to study mechanical engineering.
very good. Caleb, what about you?
I plan on attending Cal Poly Pomona for a degree in electromechanical engineering.
Nice. And Zach, what about you?
I plan on attending Boise State for mechanical engineering.
Awesome. All right. Very good. Nick, any follow-up questions for anybody?
No, I just, I want to say thank you to you guys for representing the engineering sector, and for, congratulations to all of you too. You're right here at the tail end, and congratulations on graduation. And I hope you enjoy these last few weeks as much as possible. But thank you for being a part of this.
All right. Well, this concludes the 2021 RUSD CTE Showcase Industry Sector Panel Discussion for the industry sectors of architectural design, engineering design, and robotics and engineering systems. I want to thank the student panel, and I'd also like to thank Nick for joining us and all the valuable input that we got today. I'd also like to thank our industry partners watching the video for supporting RUSD CTE students. RUSD Career Technical Education, where students are career ready, period.